Shovan, Karan, Francesco. Our research involves the use of energy and water systems integrated holistically to create a potential infrastructure in the settlement of Dharavi in Mumbai. Our process involves a background research and problems and solutions identified and technologies that are going to be used. So Dharavi is rapidly densifying, and the key issue is that we are addressing is that there are over 1 million people living in just 2 square meters of square kilometers of space, and average size is 4.6 people in a household. So our 4.6 in a household. The Dharavi is located between the Arabian Sea and the Methi River. As you can see, it's in the center of Mumbai, and most of the settlement is powered by electricity and has access to water, but there is a lack of clean water in the settlement. So we identified the issues we are going to be dealing with is the water and the energy crisis. In Mumbai, over 3 months, there's very high rainfall. That's June, July, and August, with excess flooding over the three months. Also, there's very high levels of humidity. Most of the settlement has very little access to water, less than 20 liters a day per person, and due to high levels of contamination, there are a lot of diseases. With the electricity they are highly dependent on the grid of the city, and there are constant issues with electricity all across the year. And the distribution is uneven with a lot of unsophisticated use of technology across the settlement. So we hope to create a circular system where we can integrate all these problems and create one infrastructure that would address and create a self-independent system of water and energy crisis, including mitigation of flooding across those 3 months.
So when it comes to, we identified these problems based on the research, and as Shovan mentioned, our whole drive was towards creating this integrated system using technology. We realized there are certain things that really stood out for us in the research that we did on climate. So for example, certain months of the year, it's very humid, very sunny, plenty of sunlight hours, but quite dry, even though it's quite humid, but there's very scant rainfall. And then suddenly you have 3 months of intense, 3 to 4 months of intense monsoon, where very little sun, very high cloud cover, but extreme flooding, so which causes all the destruction. And then again, it kind of goes back to the humid and sunny. So we realized that the integrated system will have to work in this dual fashion. It will not only need to be using, let's say, the water and all, but of course, when it comes to the monsoon, it was pretty clear to us that we have to harvest the water. We have to decontaminate that. And then similarly, when it comes to the dry season, not only will we obviously capitalize on solar energy, which is abundant, but also start using humidity and salvaging moisture from the atmosphere. So, as has already been pointed out, it's the integrated system, and it works with water as well as with energy. And then we detail how we try to bring it down to storage and distribution levels. So essentially, when we are looking at the settlement, another thing, as Shovan also pointed out, we're talking about the scale of a settlement which is about across 2 square kilometers, but very, very dense, very highly populated. So we realized that it cannot be that we put one solution, only one kind of technology, and it serves the whole population. We had to break this down into different segments and look at each neighborhood, looking at a sample size of say 5 to 6 households, and then make them autonomous, and then across, and this series of nodes then can be linked to create the system. So it works at the urban scale across the settlement, as well as the neighborhood scale, which are utilizing existing courtyards without any demolitions or excavations. So what we were imagining was that this integrated system would be something that can be self-assembled by the community, going with one of what we mentioned in our first slide manifesto, which was not only energy and water, but also development with the community. So if we are developing this system, it cannot be something that just will be plonked upon by us, but it is deployed given to the community, and then it is constructed by them, assembled, and according to their own needs and demands. So for this we realized there are a couple of new aspects that also come in, which is the material and how to make it completely, to package it, to make it compact, and something that can be created as a toolkit. So this is something that we were playing around with in terms of the prototype. This is just a conceptual kind of idea of the sketch. This is sort of where we started off with. Initially we were exploring different forms architecturally, whether it is the umbrella or there are other systems, but we realized that if we have to break it down into simple components, the prototype should consist of a kind of catchment which can capture the solar as well as the water. There's a filtration system, so it needs a kind of a verticality, and then there is a storage and a distribution system which kind of spreads across the courtyard. The other thing is that if this is to become an architectural object, which is put into the urban fabric, then the bottom part is also acting as kind of an urban furniture. So it becomes a part of the settlement, it becomes a part of the landscape itself. And this is kind of how we were imagining these things with the scale, but just a rough conceptual idea of how they can be linked in different areas. And similarly, at the human scale, it becomes a part of the furniture of the street itself. So, and one big advantage that can happen is because of the raised plinth in monsoon, this would give some kind of resilience architecturally.
Finally, regarding the technology implemented in this project, we just thought about it like pretty much the questions were like how to integrate all of these systems in something that is deployable, kind of like with the whole problem of the class, how to look ahead when we have in advance. So we certainly was extremely useful to go back to the tool of parts provided by us in this class to select the technologies that have already been proven and implemented in a lot of other MIT research and put it in here. So we kind of have this sandwich layer of funnel that would incorporate graphene membranes for water decontamination that will be activated by the solar energy collected by the solar panels, a waterproof membrane that will keep the water inside, and a self-folding skin that I will kind of explain very soon with another set of integrated member materials, and finally an exterior skin is a humid condenser that would include some sort of highly surface area to capture that moist during the summer seasons. And we were truly inspired by the work done around the corner in the self-assembly lab, precisely because we really gave a lot of thought about the materiality and what modularity means in this day and age. And I think we thought the most fascinating concept of modularity, kind of an stretch of it, will be the self-assembly materials developed by the lab, because they would allow us to integrate both the flexibility of a material that contained liquid and the portability and the deployment. So I thought it was kind of spot on. And and this was a video, another experiment by the self-assembly lab, which teaches about the entire tower based on very simple algorithms. And once again, the reference that we've been working on are pleated materials that will just collapse. The new NASA integrated solar system into 4D printing, which is also another technology being developed at MIT that will have solar panels kind of 3D printed with different kinds of alloys. And finally, based on inspired on Janet Eggman's art pieces, some sort of an urban object. Finally, all the elements that we incorporated throughout that we just found in the toolkit was the graphene membrane and electrical cleaning. In the interior surface of the prototype, humidity condenser, inspired by a lot of the fascinating work being done in East Africa and in the South American areas, where they just implement a lot of fabric and area around a big tower to collect that moist. And last but not least, how can we implement not only a high efficiency solar panel, but maybe even a augmented solar panel with some sort of Fresnel lens to even increase that efficiency. Thank you very much.
But the whole idea is that this is the neighborhood with the artery, and we were using the plan of the community that we showed before, and how these can be within the system itself and have interlinked networks.